Okay, to demonstrate this, I have the fan. This is just sort of a random sample that I've pulled out of inventory and taken outside here. I'm just outside the shop, and I've got a 10-watt panel, which is standard for this kit, and we're just sort of plugged into the panel and running the fan. Now, if you notice, I have the panel sort of pointing directly at the sun. This would be aimed so that the fan is running at its max power. And to demonstrate that, we have the fan sitting here running. So what I'm going to do is I'm going to get the anemometer, and we're going to get a reading for this position to show the performance at max power point. Then what we're going to do is we're going to move the panel, and we're going to face it in different directions to show the difference in performance and why it's important that the panel is actually aimed at the point in the sky where the sun will be at the time you want peak performance out of your fan. So basically what I want to demonstrate in this video is the importance of the direction that the sunlight enters the panel. And what I mean by that is when we're looking at the solar panel and how this operates, the sun ray is going to be coming off of the sun, and it's going to be traveling towards us, and it's got a direction that it's traveling. And what we're constantly seeking in terms of max power point and the maximum production that a solar panel can produce is to have that sun ray enter the panel at a 90-degree angle. So for example, this is lifted up, it's not flat, and the reason that is if we look at the panel from the side, I'm going to just sort of try to do this without making a bad camera shot here. Okay, so this is the solar panel, and my pin over here, let me get it onto the screen, my pin is the sun ray. So when we have the sun ray coming from the sun, we want it to hit the panel and enter at a 90-degree angle straight into that solar cell. If we're coming in at an angle that's sort of, say, like this, or maybe the sun's coming like this, or like this, any of those angles are not going to be 90 degrees. So what I'm going to do is sort of demonstrate how that affects the performance. So you might ask yourself, what is he on about this sunlight that needs to enter this at 90-degree angles? Well, if you think of it, what's going on here is these solar cells are absorbing the sunlight, and the actual production is going to have to do with how efficiently the energy from the sun can enter this cell at an optimum angle so that it moves electrons inside that solar cell into our circuit as electricity that flows out to the fan. So if you think of using maybe a water hose, like you're going to try and like blast some paint off a wall using a water hose, and we're going to think of the water hose as sort of being the sunlight. Actually, the water coming out of that water hose is going to be the sunlight, and whatever we're trying to blast off, we want to hit that with the strongest angle we can so we knock it loose, right? It's very, very much the same thing in terms of how sunlight affects the performance of a solar panel, with specific respect to the angle of the panel and how the light is actually absorbed. Okay, I've placed the anemometer in front of the fan, and this is our velocity reading with the setup where we have, just kind of pan back on this so you can see it, where we have the panel facing the sun directly. Now I'm going to take the panel, and we're just going to move this facing another direction. We're just going to grab it. We're going to say, okay, the direction it's facing right now is southwest, and I'm going to say what we're going to do is we're going to point the panel really the wrong direction. We're going to aim it north, and we're going to show how the fan performs with the panel facing north. Alright, so looking at this, looking at the fan directly, you can see we've lost quite a bit of velocity. And we're barely moving the anemometer. I'm going to try and put it back next to the fan and see if that gains us anything, but it looks like it just doesn't even read. Okay, so the panel is facing the wrong direction, which is north, and it's tilted upward. If you notice that the shadow is sort of really short, and when we had it facing the other direction, it was really long. So what I'm going to do at this point is I'm going to face this panel due west. And we're going to take a look at what the performance is facing this direction. Okay. Now, right out of the gate, we've got quite a bit better performance out of the fan. Now, mind you, I did move this anemometer back a little closer to the fan blade since we weren't getting any reading on that last angle. This is what we're reading at this point. Okay? So you might ask yourself, what happens if the panel is just mounted flat? We just lay it on the ground. Alright, it's just laying there. Let's see what we get. I don't know if you guys can see that. I can't see the exact readings filming this, but I believe that's about half the performance. So this illustrates why the 90-degree sun angle on the panel, in terms of the way that the light actually enters the solar panel, affects the production of the panel, and therefore the velocity of the fan. So in terms of shade, since we know that it's running directly off the panel, and the power that's being produced is a result of the sunlight, let's see what happens if we just shade a corner of this panel. Throw a little coffee can right there. That's one whole corner. As you can see, I've got it on one cell, one section of cells, one grouping there. Let's take a look. And I could tell you I'm not even going to waste your time in putting the camera down there, because obviously we have no performance. It is spinning, but we have no performance. Let's see what happens if we cross. Okay, you see that shadow? We've crossed this group of cells here, and this other group of cells here. Both of these have been crossed. And, you know, if we look over here really closely, these guys are wired together inside the panel. So the question is, how's that going to affect the performance of the fan? Even slower. So what we want for the peak performance of this unit is for it to have the panel aimed at the spot in the sky where the sun is located at the time of day that you want peak performance. So for example, let me just pan up here, try not to burn out the camera. So we want to aim it at the sun. We're obviously not aimed at the sun. We have a shade shade going on here with this, so let's just go ahead and lift this guy up. If I can get it, hold the camera at the same time. Terrible camera shot. Anyway, we've got it. Looks like I got it pretty well aimed. That shadow's nice and long. Lines up pretty evenly with the frame of the panel. And of course, our performance is going to be correct. Okay, we have the Gem and Mineral show going on next door, so I had to edit this. We had a little noise in between. But anyway, here we are. This is our performance with the panel aimed at the sun. So to demonstrate what I mean by that, what we're constantly seeking in terms of making the panel perform sort of exact at its peak performance, we want the sunlight to come into the panel. Just imagine my pen as a ray of sunlight. It's coming down, and what we want it to do is strike the panel and enter the cell at a 90-degree angle. So to do that, we're going to want to have the panel aimed at the sun.